have passed your destination.
Do you struggle with direction and magnitude? Try vectors. What are vectors?
Vectors are awesome. Vectors are used in math and science to help determine the position of one point in space relative to another. They have direction as well as magnitude.
Wow! And just for $15.99, a pack of 10 moldable vectors can be yours.
Cool! Thanks, vectors!
This is a vector. It has both a head and a tail. Vectors can be written using a letter with an arrow over it. Then, to show the numerical value of a vector, use a chevron symbol and include at least two components of the vector. Given vector A with points on the origin and a point at 2, 3, you can find the magnitude of this vector using the distance formula. The magnitude of this vector would be the square root of 13. Now you know how to calculate it, but what is magnitude? Essentially, magnitude is the numerical value of the length of the vector. But what is direction? Direction is whichever way the head of the vector is facing. For example, here the vector would be pointing northeast.
Where are you headed today?
Chicago?
Where are you coming from?
Kankakee.
There's a faster route using vectors! Vectors can help you get from point A to point B faster. By adding the two vectors, you can get a vector that goes to the straight, direct path.
Let's say you're going along the path of vector A, and then you turn and go along the path of vector B to get to point C. Well, you can get there by just simply adding those two vectors. So, to add vectors, first add the first two components of each vector. Then add the second two components of each vector. Next, you will get a new vector. You can even use vectors to help you determine whether two cars will crash. Let's say you have car A and then you have car B going along this vector line. What you can do is first combine each vector line separately. So, for example, in car A, you would distribute the x across the direction vector and then add it to the initial vector. Then, to find the point of intersection, make each component equal to the component of the other vector line.
Continue setting these components equal to each other and solve.
Then you have found your intersection. That vector of intersection would be 6, 3, 2. How do you know this? Because both of the first components are equal to 6. Both of the second components are equal to 3. And both of the third components are equal to 2. But just because two vector lines may intersect, that doesn't necessarily mean that the cars will crash. The variables x and y represent a function of time. So, since x and y aren't equal to each other, then you know that the cars will not crash.
Wow,
You can also use vectors to find the angle of intersection. If you have car A traveling along the path of the following vector equation and a car B traveling along the path of the second vector equation, first take the dot product of the two direction vectors. So, the direction vector is whatever is being multiplied by the variable. So, dot products are symbolized by using a dot in between two vectors. To take a dot product, you must multiply each of the components and then
add each of those products together. Thus, the dot product be -7. Then, take the magnitudes of the two direction vectors. Once you have the magnitudes, you can set up an equation. First, you would put the dot product in the numerator. Then you would put the two magnitudes multiplied by each other in the denominator. Then to find the angle, you would take the cosine inverse of this entire number, and that would be the angle of intersection.
Get the 10-piece vector pack for just $15.99 plus shipping and handling. Buy 2 and we'll throw in a free instruction manual about how you can use vectors to improve your driving. That's a 20-piece vector packet for one small payment of $15.99. Hurry, this offer won't last long. Must be 18 years or older to order. Not responsible for damages or items lost in shipping and handling.
Yay, vectors!
I've got sunshine on a cloudy day.